This unit is split into two sections. The first looks at all you need to know about light. The second covers sound. Let's start with the behaviour of light and shadows. Light is a form of energy that travels at incredibly high speed, and we detect it, obviously, by using our eyes. But where does light come from? What is the source of all this light, and why do some things appear brighter than others?
Why can you see a cat's eyes in the dark?
They glow, don't they?
Yeah, they're really bright.
I think it's something to do with them being able to see in the dark. Well, cats can see in the dark, can't they? It's because their eyes shine. I don't know. We need science in action to investigate.
I'm onto it. My dark lab seems the perfect place to start. Maybe Boffin here can help. So why can I see her eyes in the dark? The light from the torch reflects off Boffin's eyes and enters mine, so I can see them. Without a light source, I can't see anything at all.
We can see luminous sources. For example, these optical fibres, light bulbs, the sun and other stars, because of the light they give out which enters our eyes. We can also see non-luminous objects, such as these pillars and the studio, because light from a luminous source is reflected off them into our eyes. So for light, you need to know that luminous means that something gives out its own light. Non-luminous means that an object does not give out light and can only be seen because it reflects light. Explain, using a diagram, how you can read a book using the light from a bedside lamp. Your diagram would look like this. The arrow leaves the light source, hits the book, and then reflects back and travels to your eyes. Make sure you draw the arrows leaving the light source and travelling towards your eyes, and not the other way round. Most surfaces reflect light, but unlike most everyday things, mirrors have a smooth surface and therefore reflect light in a regular and predictable way. Light is reflected from a mirror at the same angle as it hits it. And remember, light only ever travels in straight lines.
Everything you see is a result of light travelling into your eyes, and light can only travel in straight lines like this. If light was curved, then you could see round corners. And as we can see from this, that's not the case. And the only way we can see this light is when all the holes are lined up in a straight line. You can see this happening when I use this flexible mirror. If we look closer up, we can see the light rays shining directly onto the surface of the mirror. When I use this prong to bend the mirror's surface, the light rays bounce off the mirror's surface at different angles, giving a distorted image. But when the surface is flat, the reflected rays of light are parallel. They all reflect back in the same direction. And when those rays go into my eye, I can see an undistorted image of myself. A mirror is a flat, shiny surface, and most of the light that hits it reflects or bounces back.
How mirrors reflect light is a key concept in this unit, and for your test you really need to understand it well. The ray of light striking the mirror is called the incident ray, and the ray leaving the mirror is called the reflected ray. The angle of incidence is measured with a protractor from the dotted line called the normal, and this angle of incidence, I, will always be the same as the angle of reflection, R. So you should know that mirrors always reflect light in a predictable way. A plane mirror will always reflect light at the same angle as the light strikes the surface. This relationship can be summed up by the equation the angle of incidence I equals the angle of reflection R. So we've seen that light is reflected when it hits a shiny surface. But what happens when it meets a transparent material?
Take a close look at the stick. It looks as if it has a bend in it, a sharp bend. But from here, it looks normal, perfectly straight and no bends. When light travels from air into water or anything else that lets light through, like glass and plastic, it gets bent, it changes direction. Take a look at these. All these shapes are made out of glass. Glass lets light through it, like water does. It's transparent. See how the light bends as light passes through them. The most bending takes place at the edges, where the light moves from air to glass or glass to air. This bending effect is called refraction, and we can use it to do some useful things.
Refraction is caused by the speed of the light changing as it passes into one substance from another. But be warned, if the light passes into and out of one of these transparent materials at right angles to the surface, then the light ray passes through with no change of direction. This time, let's look at what happens when white light passes through a glass prism.
If I pass the light through a prism, it's refracted. Something else happens. White light entering the prism, but all these colours coming out. Well, this is dispersion. And what we're actually seeing is what makes up white light, all the colours of the rainbow. And this is why the sky is blue and a sunset is orange.
This range of colours that's produced by the dispersion of white light is called a spectrum. And for your test, you need to know the names and the order of the colours. So we've got a rhyme to help you. This range of colours can be remembered using this rhyme. Richard of York gave battle in vain, starting with R for red, O for orange, Y for yellow, G for green, B for blue, I for indigo, and V for violet. So, for your test, you need to be clear about refraction and dispersion. Here are some key definitions to help you. You need to know that refraction occurs when light crosses the boundary between one transparent medium and another. For example, air to glass or air to water. Dispersion is the process when white light passes through a prism and splits up into a range of colours, called the spectrum.
Try to make sure you use the right words when answering questions. So, for example, in a light question, the light would be shining onto a surface. Talk about the light being reflected off the surface rather than bounced away from the surface.
Light rays travel in straight lines, so if you're asked to draw a ray of light, please use a pencil and a ruler. If you don't, you will not get the marks.
First of all, coloured filters. These are translucent. That means they allow some light to pass through, while some of the light is absorbed by the filter. Very simply, the colour of the light is the colour of the filter that it passes through. Remember, the filter has absorbed all of the other colours. Here in the studio, we have used a magenta filter and a blue filter to create this backdrop. No coloured filter, and we are left with white light. So the key point you need to know about coloured filters is simply that the colour of the light that passes through the filter will be the same colour as the filter. So that brings us to the end of this section on light. If you're not sure about those light ray diagrams, why not rewind and go over the key points again? Remember, there are more practice questions in our Key Stage 3 book and on our website.